Starting with the first question, figure 3.1 shows the load extension graph for two springs A and B. Determine the extension of spring A for a load of 10 Newton. So y-axis is showing load and x-axis is telling you about the extension. So 10 Newton extension on a spring A. So this is 10 on y-axis. This is the point on a graph for spring A, and you have to locate the extension. It's between these 2 points. So if this is 10, this will be 11, this is 12, and it's between 12 and 13. So this will be 12.5, 12 and a half. Okay, so the extension is 12.5 millimeter for the 10 Newton. In part B, state which spring is easier to stretch and give a reason for your answer. Okay, so if we look at the graph, if you see for any force, even if you see for the 10 Newton force, in spring A, extension is 12.5, and if you see for spring B, the extension is greater than that, okay, for the same force. So same force is producing more extension in spring B. So spring B is easy to compress or stretch. Okay, so spring, answer is spring B. Reason is same force or same load is producing more extension. Okay, second answer, we can write the slope of the graph. The slope or gradient is less steeper for spring B. Gradient shows the spring constant, so when it's have a less value of spring constant, so it's easier to compress or stretch. In the part C, we have a different spring is suspended from the edge of the bench, and with no load on the spring, the pin points at 19.7, and when there is a load, it points at a different 13.9 centimeters when the load is 6 Newton. We have to find extension when the load is 6. Okay, extension is basically it's a change in length. Final length is 3.9, initial length was 19.7. So 43.9 minus 19.7, subtracting both, that will give you 24.2 centimeters. In the next part, they're asking you to describe how a student could use the equipment in figure 3.2 to obtain accurate reading for a load extension graph for the spring. Okay, there are many possible answers. Some of them are measuring extension for different loads. Okay, we can change the load and measure the different extension for different loads. Secondly, we can avoid the parallax error. How we can take reading from ruler with eye level with pin. Okay, and third point, we can write 2 points are enough for 2 marks, but the another possible point is that we can repeat experiment for same load and find average. That will also improve the precision of the reading. Okay. In the next question 2a, we have a aircraft and there are different forces acting on it. We have to find resultant force. Okay, so as we know, opposite forces will cancel with each other. 15 Newton force is acting upward, and exactly there is a opposite force 15 Newton that is acting downward. So they will cancel each other. So this 15 will cancel out this 15. Okay, so we are only left with two forces. One is acting leftward and one is acting rightward. So for solving that, that is 19 Newton and 11 Newton. They will be subtracted. So it will be 19.0 minus 11.0 Newton. That will give you 8 Newton, and the direction will be in the direction of greater force. So 19 is the greater force, so 8 Newton in left direction. Okay, so this is 8 and direction is left side. Second part, describe the change in motion of the model aircraft. So as there is a resultant force, so whenever there is a resultant force, the model aircraft will accelerate. Okay, model aircraft will accelerate due to resultant force. Okay, in 2b, the horizontal force acting on the model aircraft become balanced. Suggest how the horizontal force acting on the model aircraft have changed. How it can be changed? With increase in speed or velocity, air resistance, drag force will also increase. Okay, we have to state Newton's first law. So first law is law of inertia. You have to write down the definition. In question 3b, Newton's second law describe the change in motion caused by resultant force. State the equation which link acceleration, resultant force and mass. You just have to write down the Newton's second law, that is force is equals to mass time acceleration, F is equals to ma. In question 3c, state what happens to the motion of a moving object when resultant force is applied to it in the opposite direction of the motion. Okay, whenever the resultant force is opposite to the direction of motion, the object will slow down. Okay, so object will slow down, or we can write it will decelerate. Okay, question 3d, state what happened to the motion of a moving object when a resultant force is applied to its perpendicular direction. So when it applied to the perpendicular direction, it will change its direction. It will change its direction. In question 4a, a truck of mass 8 kg is rolling down a slight incline as shown in the figure. The truck travels at a constant speed. Explain why the truck does not accelerate even though it is on an inclined plane. Okay, so it's not accelerating even it is on an inclined plane. So we can say that the forces acting on it are balanced. This is first point. Second point is balanced. Why balanced? Because incline is very small. Okay, so as the incline is very small, so the frictional force and the downward force will balance each other, so it will not accelerate. The slope of the incline is increased. As a result of this, the truck now accelerate. Explain why the truck now accelerate. Okay, when you increase the incline, so forces will not be balanced because it's accelerating. Forces are not balanced. Why? Because we can say that force acting downwards is increased due to increase in inclination. Okay. Question 4c. The truck accelerate at 2 meter per second square. You have to find resultant force. So resultant force F is equals to ma. Mass was given. This is the mass, 8 kg. So 8, acceleration is 2. That will give you 16 Newton. So 16 Newton is the answer. In the question 4d, the acceleration of the truck can be increased by reducing the force of friction. Suggest a way of reducing the friction in this investigation. How we can reduce the friction? For reducing friction, we can lubricate the wheels or surface. That will reduce friction. Or we can use smoother surface. Okay, that will also reduce the friction. 5a. Show a man pulling a child on a sledge. The mass of the child and the sledge, its combined mass, is 42 kg. The unbalanced force acting on the sledge is 46 Newton. State the magnitude of the forces that need to be exerted by the man to make the sledge move. Okay, so we have a backward acting force and we have a mass of the object. So how much force is required to move the sledge? We need at least 46 Newton force in the forward direction to move, 46 for the balancing, and greater than 46 to move the object in the forward direction. So answer will be more than 46 Newton. And question 5b, name the forces that is opposing the motion of the sledge. Okay, opposing force is mostly friction. Question 5c. The sledge is then placed at the top of the hill and accelerate down the hill at 0.75 meter per second square. So this is basically acceleration. Calculate the resultant force acting on it. So F is equals to ma is the relation we have to use. Mass was given, mass was 42 kg. So 42, acceleration is 0.75. Multiplying both of them gives you 31.5 Newton. Okay, so that is the resultant force. Assuming that the forces opposing the motion of the sledge is the same, calculate the total force acting down the hill. You may draw a diagram in your answer. Okay, so we have to assume that the force opposing the motion of the sledge is same that was given before. Okay, and we have to calculate the total force acting down the hill. And okay, so let's make a scenario. Let's suppose this is inclined plane and there is some sledge placed on it. Okay, so this is the, let's suppose this is the point where the force is acting and the sledge is moving. Motion is downwards. This is the direction of motion. Okay, and resultant force is also in this direction. Resultant force that we have calculated is also in this direction, that is 31.5 Newton. And The friction force is opposite to the motion. Friction is 46 Newton. Okay, so total force acting downhill is total force acting, that is, that must be okay, we can make an equation for the resultant force first. Resultant force is down in the downward direction, na? So there is a resultant force that is in the downward direction, and there is another force that is a downward force. Okay, downward force, let's call it D, and let's call the resultant force R, and let's call the frictional force F. Okay, so resultant force is equals to R is equals to is the difference of downward force minus friction force. Okay, why D minus F? Because D is greater, because object is moving in the direction of D force, okay, downward force, and the resultant force is also in that direction, so that's mean that the downward force is greater. So greater force minus the lesser force gives you the resultant force. Why we are subtracting? Because both the forces are acting in the opposite direction. Okay, we have to find D, so this F will go on left side, so D will be R plus F. R is the resultant force, that is 31.5. F is 46. Adding both of them, you get 77.5 Newton. Okay. In the next question, a student is using some 50-gram mass. Calculate the weight of 50-gram mass. Okay, you have to calculate the weight. First of all, mass is given, that is 50 grams. You have to convert it into kg. So 50 divided by 1000, that will change into kilogram. So this will be 0.05 kg. So W is equals to mg. So 0.05 multiplied by 9.81. The answer is 0.49 Newton. Question 1b. A student uses the 50-gram mass as load to stretch a spring. Shows the apparatus the student uses to obtain reading for a load extension graph. Describe how the student could use the apparatus and measure that the readings are accurate. Okay, how we can measure? It's a 4-mark question, so we have to write at least 4 points. Okay, starting with the first one, we can write fix the ruler vertically. Second point can be add, it's a second step, add masses to the spring. Third is ensure eye level with pin to take reading. And the fourth one is ensure load is stationary. The fifth possible point is repeat for different loads. Okay, you have to write any 4 of them for 4-marker question. In the question 2a, the mass of a small steel ball is 120 grams. The volume is 16 centimeter cube. You have to find the density. So density is equals to mass divided by volume. Okay, so mass is 120, volume is 16. That will give you 7.50 grams per centimeter cube. In the next part, the ball falls to the ground from rest. So this is initial velocity. At a time of 0.2 seconds after it started to fall, it accelerates at this rate. State the acceleration of the ball at a time of 0.1 second after it started to fall. Okay, so basically it's a free fall case, and as the acceleration, the more precise value of acceleration is, it's not 10, it's basically 9.81. Okay, so in the free fall case, the maximum possible acceleration is 9.81 meter per second square. So if there is no air resistance after zero point 0.1 second, the acceleration will remain same and its value will be 9.81 meter per second square. Shows the vertical forces that act on a large plastic ball as it is falling. State the name given to the each of the forces. Okay, we have to name the forces. The downward force, that is basically weight, and this force is basically the air resistance. In second part, calculate the size of the resultant force. Okay, as the both the forces are acting in opposite direction, so resultant force will be their difference. 1.2 minus 0.3, that will give us 0.9 Newton. Okay, so this is a resultant force. In question 3a, the load is attached to a spring as shown in figure. Two arrows indicate the vertical forces acting on the load. The spring and a load are stationary. State the name of the force acting vertically downward. So downward acting force, we can say it's gravity, or we can name it weight. Okay, weight is also a force of gravity on some mass. The vertical force that act upward is 4 Newton. State the value of the force acting vertically downwards. Okay, so there is a hint to solve the question. Basically, the spring was stationary. Stationary mean it's balanced, so the amount of force acting downward, the same amount will be acting upward. Okay, so if this is 4 Newton, the downwards acting force will also be 4 Newton. Question 3b, the load is pulled downwards and then released. The load move up and down. Represent the vertical forces acting on the load at some time after it is released. Calculate the resultant force on the load and state its direction. Okay, so there are two forces, one is 7.6, one is 2.8. So resultant force will be greater force minus the lesser one. 2.8, it's give you 4.8. So magnitude is 4.8 and direction will be in the direction of greater force. So direction will be upwards. Okay. Question 3c, state the principle of conservation of energy. So principle of conservation of energy is energy cannot be created or destroyed. Okay, it can only be transformed into one form to another form. Second part, eventually the load stop moving up and down. Describe and explain why the load stop moving. Use your idea about conservation of energy. Why the load will stop? Because its energy will dissipate. Okay, it will lose its energy. So we can say that potential energy or kinetic energy of spring is dissipated to surrounding as heat. That is why it will stop moving. In question 4a, shows an aeroplane accelerate uniformly on a runway. The aeroplane has a mass of 3.1 into 10 raised to power 6 kg. From rest, the aeroplane reaches a speed of 70 meter per second. Okay, so from rest, it means this is u initial velocity, this is final velocity. Calculate the following quantity, the acceleration of the aeroplane. Okay, this was the time. So for the acceleration, we have a relation final velocity minus initial velocity divided by time. Final velocity is 70, initial is 0, time is 32. So solving them, we get 2.2 meter per second square. Next, we have to find the resultant force. For resultant force, we have a relation F is equals to ma. M was given in the question, that is 3.1 10 raised to power 6, and acceleration is 2.2. Multiplying both of them, we get 6820000 Newton. Question 4b. When the aeroplane reaches its destination, air traffic control directed to circle the airfield until there is a safe time to land. We have to show a head-on a view of aeroplane flying at a constant speed in circular horizontal path. Draw an arrow showing the resultant force acting on the aeroplane. Okay, so first of all, you have to consider a circular path. So the path, if you imagine, it will be like something somehow like this. Okay, so its center will be somewhere like this. So resultant force for a circular moving object is always towards the center. So this is the resultant force of the object. Okay, so if you consider this one as the circle, sorry, we if you consider this one as a circle, the resultant force will be, this is the center of the circle. Okay, if we consider the path like this, it's not a vertical circle but it's a horizontal circle. So if you consider a horizontal circle, this will be the center of the circular path, so it will be toward the center of the circle. In the question 4c, the pilot wants to decrease the radius of the circular path while maintaining a constant speed. Suggest how the pilot could achieve this. Okay, what we have to do, we have to decrease the radius by keeping the speed constant. So what we can do, we can increase speed, and the second option is, or we can decrease mass. Okay, for a circular motion, we know that the resultant force is directly proportional to the mass and the velocity square, and it's inversely proportional to the radius of the circular path. For 4D question, as the aeroplane land on the runway, it decelerates from its top speed. The resultant force on the aeroplane is less than it was at the takeoff. Explain why this is the case. Okay, in 4D, you have to explain why the resultant force is less. When the aeroplane is landing, it consumes some of its fuel. Okay, so we can say that the aeroplane has used some of its fuel. So the mass has decreased. Okay. So and we know that force is directly proportional to mass if we keep the a constant. If we have to, okay, so we can say that if the acceleration is same, the force and mass are directly proportional. So therefore force decreases. In question 5a, a resultant force act on an object at rest. State the direction of the acceleration. Okay, so resultant force acting and the object was at rest. The direction of acceleration will be in direction of motion. In direction of motion. In 5b, a resultant force act perpendicularly on a object traveling at a constant speed. State the effect of the force. It's the same repeated question that will change the direction of the object. Okay, in the question 5c, we have a man with a mass of 70 kg steps into an elevator. State the value of the force exerted on the man by the elevator. Okay, so it's a action and reaction basically. The force exerted by the person on the elevator, that is its weight, and the same force will be exerted by the elevator on the person. So we have to find the weight. W is equals to mg. M is 70 and G is 9.81. Multiplying both of them, you will get 686 Newton. And second part, calculate the force required to accelerate the man at 1.6 meter per second square. So we have to use Newton's second law. F is equals to ma. Mass was 70 and acceleration is 1.6 given. That will give you 112 Newton. That much force is required. Explain why these values are different. Okay, why these values are different is because the first force that we have found, that is the reaction, that is the weight, and the same amount is applied by the elevator on the person, that is the basically reaction force. But in the second question that we have found, that is needed for accelerating the object, that is resultant force. Okay, that is why they are different. So the force required to accelerate object is resultant force. Okay, so the so the total force required to accelerate object upwards is its weight plus the resultant force that is producing the acceleration. Okay, so that is why they are different. So if you add both of them, this will give you 798 Newton. In the next question, we have a planet orbits a star at a constant speed in a circular orbit. Which of the statement below about the forces needed to maintain this motion is correct? Okay, it's option D. The force is directed toward the center of the circle. In question 2, a car is driving around a circular track at a constant speed. Which statement describes the motion of the car? So it's option C, the car is accelerating because its velocity is changing. Question 3, in which of the following situation would no resultant force be required? It's questions part C, option C, a ship sailing at a constant speed across the ocean. Okay, in this, no resultant force is required. Okay, because there is no acceleration, it's moving in a straight path. In question 4, the moon orbits the earth at a constant speed. Which of the arrow on the diagram shows the direction of resultant force on the moon? Okay, we know that whenever object is moving in a circle, resultant force should be toward the center. So if this is a moon, this is a center, so this will be a resultant force. It's option D. Okay. Question 5. A car starts from rest and rapidly increase speed. There is a force on the car, forward acting force on the car from the engine, and a backward acting force on the car from a resistance and friction. Choose the force diagram and description that best describe the magnitude of the opposition forces. So it's the option A. Why it's option A? The forward